Hello everybody, this is AB Calculus section 1.2, day number 1 on representations of functions. Today we're going to talk about formulas, graphs, tables, and words to define and represent functions. So I'm going to keep it short here, but we're going to talk about those 4 things: formulas, graphs, tables, and words. Alright, so when working with formulas, I would review these topics in section 1.2 of your textbook. Otherwise, you will get plenty of practice with those in your problem sets. So make sure and work your way through plenty of work with formulas. Using graphs, specifically with linear functions, there's 4 topics that we like to cover, at least to review what you did in pre-calculus. First is the slope-intercept form, y equals mx plus b, where m is the slope, or represents the slope, and the y-intercept is the coordinate or ordered pair 0, b. That's useful when working with the y-intercept or trying to find the y-intercept. Point-slope form is probably your more typically, and I would say more convenient, formula for the equation of a line, where you have the slope, again, which is m, but the advantage is that you don't need to have the specific point of the y-intercept. You could have any point. Any point on that line will suffice to write the equation of a line. Okay, if 2 lines are parallel slopes are the same. So the slope of y1, let's say it's linear, would be equal to the slope of y2. For example, if the slope of y1 is -8/7, then y2, another linear function, if parallel, would have the same slope. Perpendicular slopes are opposite reciprocals, so the slope of y1 would be equivalent to the opposite reciprocal of the slope of y2. Example of that might be a slope on the first function of, 0.75, which would be 3/4, would be perpendicular to another line, y2, if the slope of y2 is -4/3. Okay, let's look at a couple of examples involving slope and equations of lines. Example 1 says find and graph the linear function that passes through the points 2, -3 and -4, 1. Okay, so we're going to write, again, after that, write the equation for this function in point slope and in slope intercept. So let's just graph these 2 points and then connect with a line. So I've got 1, 2, 1, 2, 3. So here's the point 2, -3, and -4, 1, 1, 2, 3, 4, and up 1. That's the point -4, 1. So the equation of this line can be written in point slope form using those 2 points. So let's find the slope. The slope will be equal to y2 minus y1 over x2 minus x1. And you can utilize either as y2, y1, either this is x1, y1, and x2, y2, or the other way around. Doesn't matter how you name them. So I would get a +4 over a -6, which means the slope of this line is -2/3. So the equation of the line in point slope form, I'm going to use one of these points. I think I'll choose to use this point, would be y minus y1, which is 1, then the slope times x minus x1. Since it's a -4, I'll change that to a positive, and I've got point slope form. Now slope-intercept form is going to need to be adapted algebraically. This would be y1 is equal to -2/3 x minus 8/3. And then I add 3/3 to both sides, which is the equivalent of 1, and I get a negative 5/3. So there I've got the equation of my line in point slope and slope intercept. All right, example 2. Find a value of k such that this line, 2x plus k times y is equal to 10, is perpendicular to 5x plus 2y is equal to 6. All right, so these are in what we'd call general form or standard form. We want to get them in slope-intercept form. So let's take the first equation, 2x plus k times y is equal to 10, and let's put it in y equals mx plus b form. So that would be k times y is equal to negative 2x plus 10, and so y would be equal to negative 2x over y plus 10 over y. Oops, I'm sorry, over k. These should be k values here. K's, boom, right there. Okay, now, all that I'm actually concerned about in this question is going to be this negative 2 over k, right? Because we're talking slope. So that's a value that I'm going to consider here in a moment. I don't care about the 10 over k. That has to do with the y-intercept, and it makes no difference to me at this point, in the context of this problem at least. All right, now I'm going to solve, put this into slope-intercept form as well. So 2y is equal to negative 5x plus 6. I divide by 2. I get negative 5x over 2 plus 3. The 3 is irrelevant. What I'm concerned about is the negative 5 over 2. Okay, so if these two are perpendicular, right, remember that the slope of y1 would be equal to the opposite reciprocal of the slope of y2. So I'm going to take the reciprocal of this slope here, which would be 2 over negative 5, and then the opposite of that value. So those two should be equivalent, right? Now let's solve this algebraically, just taking a couple steps to do so. This would be negative 2 over k is equal to 2 over 5. This would be true if and only if k equals negative 5. So we've got a value for k such that those two lines would be perpendicular. Let's keep moving on. All right, on to the pre-calculus topic of piecewise functions. So we're going to graph this piecewise function. I'm going to plot at least some markings here where x equals negative 1 and x equals positive 1 and y equals a positive 1. So let's first graph the equation f of x equals negative x when x is less than 0. So what does y equals negative x look like? It's a slope. It's a slope of negative 1. So I could plot a second point on here just to make sure that we have an accurate slope. That would be negative 2 comma 2. And of course, notice I have an open circle here at 0 because we are not including 0 on its domain, at least for that portion. Okay, the second portion of the piecewise would be x squared from 0 to 1. So x squared equals 0 when x equals 0, and x squared equals 1 when x equals 1. Therefore, that portion is a quadratic, again including 0 and 1 at that point. All right, and the last portion of the piecewise for f of x is 1 when x is greater than 1. So I'll have an open circle at 1 and a horizontal line headed off to infinity. That would be the graph of f of x. Let's look now at writing an equation for an already constructed piecewise graph. So this equation, which I will call g of x, is going to have 3 portions to its piecewise function. Let's write the domains first. Looks like on the first portion of the graph, our domain is going to go from 0 to 1, including 0, not 1. So that would be x is greater than or equal to 0 and less than 1. For the second part of our piecewise function, we would go from 1 inclusive up to 3 inclusive. And then for the last part of our piecewise function, x would be greater than 3. Now let's write the function itself for each of those stems of that graph. All right, so let's start with this portion here. Well, this is a line, and it's got a slope of 1, and it goes through the origin. Therefore, the equation of that line would be y, or g of x equals x. Okay, I'm going to skip to the third part of the piecewise function, and I'm going to write that as a horizontal line, so it has a slope of 0 and an output of 2. Therefore, y, or g of x, equals 2 when x is greater than 3. And we come to this piece of the piecewise function in the middle. It's also a line. We need to find its slope. So its slope would be 0 minus 0.5 over 3 minus 1. So the slope would be negative 0.5 over 2, which is equivalent to negative 1/4. Now I'm going to use either one of these 2 points. I'm going to choose to use 3, 0. Therefore, in point slope form, I would have y minus 0 is equal to negative 1/4 x minus 3. And as you can see, this 0 would disappear. It's irrelevant. And I'm going to leave it in this form. You can choose to do so unless instructed otherwise. And there is g of x written in function notation as a piecewise function. All right, we got one slide left here. Let's get to it. Okay, a couple of AP style questions. The first one, I'm actually going to use some test-taking techniques here and teach you, and you might already kind of naturally think this way as well, but I'm going to give you my take on how I would go about this problem. First of all, I see all 5 options here, right? I see 3 options here, 3 options here, 2 and 2. So why would I test x equals 1 to start? Well, first of all, because if x equals 1 does not satisfy the question above, which we'll read in a minute, and it doesn't satisfy it, boom, I got my answer, it's E. The second number that I would test is x equals 3, right? Because once if 1 satisfies, then 3 would knock off the next most possible options. So let's read the question. You'll get my test-taking technique here in a minute. The functions f and g have values shown in the table below. Great. For which values of x does f of g of x equal g of f of x? The reason for these test-taking techniques is save time. I'm not going to do f of g of x and g of f of x for all combinations. So I'm going to start specifically with f of g of 1 and g of f of 1. So let's start with x equals 1. F of g of 1. I'd be real lucky if it didn't work, because then that would give me the answer immediately. I'm guessing that doesn't happen in this case. So g of 1, it looks like is 2, and f of 2 ends up being 4. Okay, g of f of 1. F of 1 is 3. G of 3 is 4. Okay, so x equals 1 satisfies this. That just means that E is out. Okay, so the next one that I said I'd test would be x equals 3. Let's test x equals 3. So f of g of 3. Well, g of 3 is 4, and f of 4 is 1. Okay, g of f of 3. F of 3 is 5, and g of 5 is 3. Okay, so x equals 3 does not satisfy f of g of 3 equaling g of f of 3. Those are not equal, so I'm going to eliminate a and b. Okay, now at this point, clearly I would choose 5. 5 would eliminate. You could choose, I wouldn't choose 4, because obviously you know 4 is going to work. So I work with 5. So x equals 5, and we go from there. So f of g of 5 is equal to, Let's see, g of 5 is 3, f of 3 is 5. G of f of 5, f of 5 is 2, g of 2 is 1, x equals 5 does not satisfy that, therefore our answer ends up being D, as in delta. Let's look at the last example here where we talk specifically about x and y intercepts. All right, so if I want to know where the curve y equals e to the negative x minus 2 intersects the x-axis, so that would be an x-intercept. I want to know what value satisfies the following. I want to know where y equals 0. I want to know the x value when y equals 0. So I'm going to plug y equals 0 into our equation. And I'm going to solve using my knowledge of exponential functions. If you wrote this in logarithmic form, that would be the natural log of 2 is equal to negative x. So that would mean x equals negative natural log of 2. Now, you don't see that as an option up here. You might be fooled into thinking, you know, at this point, hey, natural log of 2, I'm going to pick either b or d. No, those are going to be out, because what we can do here with a coefficient of negative 1, we can bring that into the logarithm as an exponent. So x would equal ln of 2 to the negative first, which is 1/2. Okay, so right now I know that b is out, d is out, and e is out. So a y-intercept, similar to an x-intercept, is a point on the graph where x equals 0. So what I want to know is when x equals 0, what is the value of y? So I'm going to plug in a 0, and negative 0 is, again, just 0. So I'd have e to the 0 minus 2. Anything to the 0 power is 1 minus 2, ends up equaling negative 1. So there we get our answer. Looks like C will be our value. All right, guys, that's it for 1.2, day number 1. See you in the next video.